Okay, so what those of you that are at home, what you will need to do is you will need to open up your assignment for today, which is handout number 1. And what we're going to do today is we're going to go over the answers. We're going to draw information on there so that we know what we're doing, okay? So what we're going to do is we're going to apply the knowledge of what we've learned so far about simple machines. If you remember, the first question is asking you about when you did the reading of what type of engineers there were, okay? So what I'm going to do is you can put your 1 hand up for A, 2 for B, 3 for C, and 4 for D, okay? So the first question says, what type of engineer would focus with analyzing lubricating gears and bearings? Give me your fingers on which one you think it is. Okay? Okay? Eric? 2. That is correct. So the answer is B. A mechanical engineer deals with gears, lubrication, and analysis of vibration. Okay? Number 2. Which of the levers pictured is a first-class lever? So let's look over here. Over here we have our first, second, and third class lever, right? Our first class lever should have an effort, a resistance, and a fulcrum, right? So which one of them that you see where there's 2 forces going down and the fulcrum in the middle? So 1 is A, 2 is B, 3 is C. So which one do you think the answer for that one is? Based on the knowledge that a first class lever has your force and your effort here going down, fulcrum in the middle. Which one do you think? A, correct. Because if you look, you have this here going down, but instead of the arrow, what do we have instead? What do we have instead of the arrow? We have a weight. That's what that is. That's a weight. And it's still the same thing. So make sure you circle A. Okay. Now, we're going to talk about gears. We haven't really talked about a lot about gears yet, but we are going to be talking about gears later on this week. So here, we have a 1 gear here, right? A big one. Then we have another one here. And then we have another one here. And what it's telling us is it's telling us the wheel is turning in that direction. This one here. If this one is turning in that direction, which direction is this one turning? The opposite direction, correct? If it's turning this way and the gear is here, believe it or not, it's turning in the opposite direction. Okay? I promise you. So if this gear is going this direction, then this gear is doing, that direction. Okay? How about this gear? That way. This one again, right? So if we look, which one is the right one? So you've got it says that it either allows the drive and the driven gear to rotate in the same direction. The drive and the driven gear rotate in opposite direction, increases the output of the RPM, or increases the output of the torque. So the first thing we need to know is which one is the drive and which is the driven.
The drive is the first one.
This one's the drive.
And then the other 2 are just driven.
Are the derivatives. Okay, but when we're talking about it, we're talking about this one's the drive, this is a connecting gear, and this is the driven. So is it 1, 2, 3, or 4? Is it A, B, C, or D? What do you think? Kate says it's A. Okay. Okay, it is A. Yes. That's good. I'm glad you already have a concept of gear. Okay, next question. In a third class lever, the distance from the effort of the fulcrum is blank, the distance from the load resistant fulcrum to the fulcrum. So let's look. We're talking about the third class one. So our third class one here, where's our fulcrum at?
All the way to the right.
It's all the way to the end. The resistance is here and the effort's here. So on your paper, draw me a drawing of a third class lever. So, I have that. I have effort, and I have force. Everybody agree? Okay? So based on that, it says the effort to the fulcrum is blank, the distance from the load resistance to the fulcrum. So, is the effort farther away or closer to the fulcrum? So look at your diagram. So we're talking about between the distance between this and between this. So this one here is less than or equal to, less than, greater than or equal to. 1, 2, 3, or 4. You ready? See what you got. No? Okay. Are you still thinking? 2. Right. So it is B. It is less than, because if you look, of course it's less than. It's not equal to, because if it was equal to, it'd be at the same place. Okay? Let's look at the next analogy. We have a can, right? And we have a screwdriver where somebody is actually trying to open it. So, where's the fulcrum on this diagram? It would be right here, right? Or would it be here? I think it'll be there. Okay? Where is the force and where is the resistance?
The force is pushing down right there. And the
Okay.
resistance is pushing up.
Right here, right? Fantastic. So based on that, when you use to open a can of paint, the screwdriver's function is as a what? What is the screwdriver? How about you two? What do you think? 1, 2, 3, or 4? A, B, C, or D? Okay. How about you, sir? A, B, C, or D? Correct. D is the correct answer. This is the lever right here. Because you have your force here, you have your resistance here, and here's our fulcrum. Questions at the first page. Feel good so far? Okay, let's go to the second page. I'm going to give you a minute to look this over. Remember, this is a pulley system. So when we're talking about a pulley system, we had a note on there somewhere. Where is our pulley system? Here's our pulley system. So what we're looking for here is we're looking for fixed pulleys based on movable pulleys. This pulley here, is this a fixed pulley or a movable pulley? Which one do you think it is?
Fixed pulley?
Yep. So it is attached to a ring stand, right? You have one pulley system here. You have another pulley system here. You have another pulley that's down here, and that is actually attached to a weight. And then you have your strings that go down, right? And then here. Okay, so we're looking for how many pounds of effort force would the user have to exert on the rope? Well, let's start with MA first. What is MA? What does MA stand for?
Mechanical advantage.
Mechanical advantage. So if we're looking at that, we have 3 pulleys, right? 1 times 1 times 2, which equals 2. The reason why it's 1 times 1 times 2 is because this one's by itself, this one is attached. So then we're going to say MA equals FR over FE. What does FR stand for?
The resistance.
The force resistance. FE?
Effort.
Force of the effort. So based on this, it tells us that we have this pound load right here that we're trying to get is 60 pounds, right? Yep.
Yeah.
And we know that the force of the pulley is 2. So we're going to say MA. What is MA? MA is 2 times FR. What is our resistance?
Yeah, 60.
Yep. 60 over FE, right? Do we know what FE is? No, we don't. That's what we're trying to find. So FE equals 60 over 2, which equals what? 30. And that is our answer. So the answer of that one is D. Is everybody good so far?
Wait, is D?
It's D. Yes,
I
ma'am.
think I can make like a little bit different than yours, but that's the same thing.
Yeah. Because if you wanted 60, if you wanted FE by itself, you could have done it a little bit different than that. But still the same.
Yeah, I did like I multiplied FE on both sides
Uh-huh.
and then divided by 2.
Exactly. Yeah.
Pretty much.
Yeah. I just didn't show all the steps. Questions about that problem? Everybody good? Okay, let's look at the next one. The first thing I want you to do is I want you to diagram the ramp, please. What we've learned before about an inclined plane. If you remember inclined plane, here we are. Here's our formulas for inclined plane. Remember, what we're doing here is dependent on if we're trying to find IMA or AMA, okay? Remember, you're going to draw the picture of your ramp. You're going to state the height and the length of the ramp, and then we're going to do math from there, okay? So, it says, POE students using a ramp to rise an object 4 feet above the ground, and the length is 12.65 feet. So, we have a ramp. What are we going to put down here? What number?
4.
4 feet. Okay? And then the length of the ramp is what?
12.65.
Okay?
Wait, I thought it said the.
It says using the ramp to rise an object 4 feet above the ground.
I thought it was saying like that was the length of like.
It's the length of the ramp. 12.65 feet. The mechanical advantage of the ramp. So what are we trying to find again?
The.
MA again. How we did it? How did we do MA with the last problem? We did force, but we're not going to do force this time. What are we going to do here? Distance of the effort divided by distance of the resistance. There's our effort, there's our resistance. So to be able to do that, it is 12.65 feet divided by 4 feet. And what will you get? Yep, 3.163. And that is our answer. And so the answer is B. Good, everybody? If I'm going too fast, slow me down. Okay? Number 8 says below is a belt system. Pulley B is 16 inches in diameter and is driven by a pulley A, which diameter is 4 inches. If the pulley A is spinning at 60 RPMs, the pulley B is spinning at what? So the first thing you want to do is label your pulley. So if we're labeling our pulley, what are we going to label? What does it tell us about the pulleys themselves? What is it telling us about the pulleys? It's telling us the diameter.
The diameter is 16 inches.
Yep. So it's telling us diameter. So we have A and B. 16 inches is my diameter of A.
No, B.
And then,
No, B. B is
oh, this one's 4. This one is 16. Right?
yes.
All right.
And it's spinning at 60 RPM.
Okay. All right. And it's asking us for what is the pulley for B, right? So what are we going to do here? D out divided by D in. Or went in over went out. So what do we have in our dimensions? Because we have dimensions. What is our D in and our D out? Well, Miss Sloan, it's 16 over 4. Diameter in, diameter out, starting with B first and then going to A. So what is 16 divided by 4? Well, we're not done yet, are we? Because that's our D out or D in. What else do we have? RPMs, right? So where's RPMs? Does it go on the top or the bottom? It goes on the top. And we need to find when out. All right, so how do we do that? If this here is our equation, this here is what we have that we know, what can you do to find W out? Because that's what we're looking for. Well, can I multiply these two and divide by that? Okay, let me get my calculator, because I didn't tell you to bring your computer with you. So if I did 16 and a fourth, I'm going to do it this way. I'm going to do alpha y enter. I'm going to do 16. Isn't it 16? Yeah, it is 15. You're exactly right, sir. 16 divided by 4. That gives me 4. And 60 divided by 4, that gives me 15. So I have 15 as my answer. And so what I did is I made this into a number first. So I divided these two. And then after that, once I got that done, I took that answer and I divided it by this. Questions about that one? We're going to play on the calculator in a few minutes. Have y'all played on the calculator on your computer yet? We're going to pull that out today too. All right, number 9. If a simple machine requires an effort force that is less than the force of the load being moved, then the machine exhibits A, B, C, or D. Show me what you think.
Wait, is this for 8?
We're on number 9. Number 8's 15.
Yeah.
If a simple machine requires an effort force that is less than the force of the load being moved in it, and the machine exhibits, what is that called? Okay, Kate's got her answer. Okay. Choose one. Yes, A is the correct answer. Mechanical advantage. Okay, when calculating gear ratio, which of the following has an indirect relationship with each other? What that means, indirect means that something goes up and the other one goes down. which one of these are an indirect relationship? A, B, C, or D? Okay, what do y'all think? It's a guess, I know. Okay, you think that? You think that? You think that? Fantastic. It is 3. It is angle velocity.
Did anybody get it?
Yes, you did. Okay, so this here, you're just gonna go and put it in your ISM book. That is for today, handout number 1. We're gonna do handout number 2 tomorrow, handout 3 on Wednesday, and handout 4 on Friday. So what we're gonna do now is we're gonna go back to our computers, and this goes in, and I want you to take a picture of this, attach it to the assignment, and then open up your device, and we're gonna go over the calculator. Those of you that are at home, what you're gonna be doing now is you're gonna go and do your vocabulary list for this week. And you should have wrote these answers since you don't have the handout in your ISM book. And then when you come on Wednesday, I'll have your papers for you and you just have to highlight the answers.